Yeah, good morning, everyone. Actually, it's good afternoon. Um, actually, we had to begin in the morning, so it got a bit late. Well, good afternoon, everyone. I hope everyone can hear my voice. Hello. Hello.
Yes, ma'am.
Okay, fine. Good. Yeah, to starting with this particular session, once again, I would like to wish everyone a very good afternoon and welcome everyone to the workshop today. I'm honored to have such a distinguished group of dignitaries for joining us today for this particular session. Today's event or today's workshop promises an engaging and enlightening experience for all of us. Let's discuss the new ideas as we come together to learn new facts and share knowledge about all the things which are revolutionized today. I would also like to thank Science Tech Conference Organization for giving me this opportunity, a wonderful opportunity indeed, in sharing few insights on present day revolution or the changes. So let's begin this journey of learning and discovering together. And before starting with, I would like to thank all of you for being here together, being here today for this particular workshop, and hope so you will get some kind of insights here today. So I shall start with this particular session, and I really expect you will like this particular workshop today because I'm going to deal with these kind of things which are not learned earlier, but still we are implementing these kind of things today, and we are and it is becoming part of a kind of daily kind of things which we are practicing, so it shows such a big kind of impact. So what I'll be doing for this particular workshop today is not to make you people much bore about it, uh, or feel uninterested in this. We'll just discuss about the few insights which are which have come up in a couple of years these, and then the facts actually, how they are built up in the real world, using some of the kind of live examples or something like that. I would be showing it. Hope you find it very interesting. Okay, so here I'm starting with my particular workshop, and let me introduce myself over here. I'm Maheshwari. I have 18 years of experience, and throughout this 18 years of journey, I just gave many kind of seminars, and in various kind of colleges, and even universities, and online and offline kind of webinars also, webinars and seminars, and and even I've done my MC and M.TECH, and PhD is just going on. So my topic also deals with this kind of deep learning application. So that was the kind of thing which opted me to just discuss about this particular topic, which would be helpful for all of us also. Okay, so starting with this kind of workshop over here, our topic for today is revolutionizing worldwide industries using these deep learning applications. So, for this particular topic over here, revolutionizing worldwide industries, now we see this kind of revolution everywhere. We find it everywhere around us. It is not that it is the such kind of particular area where it is fixed with yes, it has to move on with the things which are not practiced earlier, and like that. So every field or every industry or every kind of environment over here today, or every person has moved towards some kind of changes in themselves, otherwise changes around them, otherwise changes in the world, I would like to say. Okay, so that is the reason why we are discussing about the revolutionizing worldwide industries here today, and we'll couple it up with this kind of things revolutionized in deep learning, and what is deep learning and how these applications are built up actually. So, based on this topic, we will also explore the transformative impact of deep learning across the sectors. As I told you just now, there are many kind of fields. There is educational field. There is your kind of software companies. Otherwise, there is like finance, or there is a medical field. All these kind of sectors are like what they are not earlier. They have been booming up to such a different kind of change. So that is what we call it as revolutionizing things. Okay, so when each and every sector is revolutionized in such a manner, we even can say that if it is revolutionizing worldwide over here. So with the power of this deep learning applications, we also can get the power as to know how revolutionized our kind of world is so far today. So, not stopping you for this particular introduction to the topic here today, I'll just go with this kind of introduction. So, as you can see, this particular picture, what actually we can define, or we can how we can introduce this so-called deep learning over here. Okay, so deep learning is nothing but it is a subset of machine learning, and machine learning is nothing but a subset of artificial intelligence. So what we find over here is nothing but, here it is introduced as we go to, before getting in deeper to this deep learning, what we have to also know is what is artificial intelligence over here. Okay, artificial intelligence is a technique that allows a machine to mimic human behavior, isn't it? So now why actually we have to use this kind of artificial intelligence? It is nothing but to achieve AI by using some kind of algorithms over here, so that we can get some kind of outcome over here. Okay. Now, machine learning is nothing but it is a technique to achieve AI methods through by using some kind of algorithm and then train the kind of output what we are going to get over here. As per the trained kind of insights, whatever we get that kind of output over here. Now, coming to this deep learning over here, it is a type of machine learning inspired by the structure of a human brain. So the so-called deep learning is nothing but a machine learning inspired by the structure of a human brain. In terms of deep learning, the structure is called as artificial neural networks. We all must have been acquainted with this kind of neurons, isn't it? So this in that particular way, the data is trained, and as per that particular algorithm, we are going to get some kind of what a trained kind of data from that. So automatically we can say that whatever the humans are trying to capture or extract the data, that can with that particular data we can like we can use apply those particular methods to using these algorithm to get some kind of trained kind of outcomes over here. Say for example over here, I just use a term called training data. Okay, so what kind of data? Almost whatever is existing in this world, whatever can be described, whatever can be described over here, we can just give some kind of uh, data to it. Now say for example here we have some kind of pictures available over here. Not only this, now I have displayed a vegetable, that is tomato, and a fruit over here as cherry. Or if not that, you can take a mango, you can take or any other kind of fruits or vegetables or anything. So everything can differ as per some kind of specifications. Those specifications are nothing but over here size, type of stem, or the shape, or any other kind of attributes what you want to include in training that kind of data. So now over here we can develop a particular machine by providing the kind of insights about its features, that it is going to expect this kind of features from this. If this it is this particular size, it is going to be this particular vegetable. Otherwise, if it has such a kind of type of stem, otherwise it is of this particular shape, then it is going to be of this particular what fruit. Like this we can train that particular data. Now when we are applying this for our deep learning, now as we are going into this particular deep learning, what we actually have over here is whatever data, whatever insights we have given over here, whatever insights we have given over here, those particular insights are accepted as in the form of methods or an algorithm, and they are sent into this particular neurons. Okay, so now instead of specifying it as neurons, we can just tell it as a neural networks. Okay, so this is how the neurons actually display. So there are some kind of insights available over here in the form of methods which are sent as input to these particular fixed kind of neurons, and they generate some kind of outcome, which out of that selective kind of things which are suitable to our particular application are selected over here. So as per that, we are going to select that particular objective whatever we have featured for the trained data. Next, we'll discuss about another example, saying that here we are just seeing about how this neural networks also works in this deep learning. Okay, so over here, if you want, if there are some kind of students who have written, whom you're asking them to write a particular letter, otherwise numbers or anything. So as we are looking at it, we can easily identify the changes in the handwriting, and we actually, by looking at the handwriting, we can just specify that which student has written in this. But we want to do that this particular procedure with this particular kind of machine. So using this machine, how actually we want to do is nothing but we are going to apply the kind of concepts of deep learning algorithms. Now you find it over here. Now, in this particular identification of this nine, what are the kind of insights we are going to give over here is towards the x-axis and y-axis, we'll be having the certain kind of pixels. And if you just identify these kind of pixels along x-axis and y-axis, you get some 784 kind of nodes available over here. Those nodes are collecting some kind of data from this particular image. Otherwise you are using any kind of direct data, and that particular data can be a supervised, unsupervised, or anything, whatever it is, you are just giving that particular data and it is selecting a certain kind of neurons over here. Now these are nothing but some kind of fixed identifications which are already available. It will detect those particular identifications from these already available data over here, and as per that it is going to sum up it over here. Out of all that, they are going to be matched with a particular outcome, and we are going to select those particular kind of data which we require. So it looks same as this. So if we just collect this kind of pixel here, 28 along x-axis and 28 along y-axis, we totally get 784 pixels over here. As you can see, there are neurons over here fixed, and there are various kind of channels mapping. Actually, even you can say it as mapping as 0 1 0 2 0 3 or 0 4 0 5, like this. You can give some kind of pairs over here. Then as per that you will be collecting some kind of outcome. Okay, so from that so called outcome over here, which are fetched from this collective neurons and various kind of channels, this is what you will get the outcome over here, that is called as the output layer. Okay, so you have 0 1 2 3 4 5 6 so on, like this. You have 9 outcomes over here. So that is nothing but x1 into 0, 0.1, x2 into 0.8, x3 into something like this. You keep on using that kind of data over here. That is nothing but how you calculate the activation function. Now, there's another example for you here today. So, not only about vegetables, I said you can, or fruits or anything, you can just take you can take human persons. Otherwise, you can take like this example, which is displayed on the screen, a dog and a cat, differentiating between a dog and a cat. So, these are the three layers which exist in this neural networks. Okay, and you set some kind of insights, from this particular dog as an input. Okay, so now when you're sending this kind of input over here, then it is going to search for this data whichever is hidden over here, and as per that it is going to send an outcome about it. And based upon this kind of data, whatever is matched, it is going to decide over here what actually it is. So it detects here as it is a dog. Suppose if you are sending these kind of insights of a cat, then it is going to accept the data over here as input, and that data is going to be mapped with the kind of fixed kind of methods which are available over here, and it is going to configure that kind of validate that kind of data, and as per that it is going to display as a cat. Okay, so it has a kind of neural networks. It consists of three particular layers, that is input layer, hidden, and output layer. Next, to sum up overall about this particular deep learning over here, we go through these particular three layers. The first layer is nothing but the input layer, which we have seen earlier in this input layer. We have seen in this particular diagram that input layer, hidden, and output layer. So we will be discussing about this data. Now, what is data over here? Data is something which is not organized, okay, and which is in collective form, where you want to use all that kind of data in order to identify or train that particular data and pass it over here like this. Now when it is passed in the form of these three phases over here, or three layers, then you will get some kind of prediction. Okay, and it is not must that that prediction, whatever it is giving, it is going to be suitable to us or it's not going to be suitable. So whatever it is going to identify that it is a dog or it is a cat. If the attributes what are given as insights, if it's not a cat, then it is going to display that it's not a cat, it is a dog. So like this, the data is going to be collected. Next, what is the best part over here about this particular deep learning here is its computational power. Okay, so the generally for the normal kind of computer systems, we just see for the CPU power and all that. Okay, so we check for all that kind of power. But in this kind of deep learning, we just try to check for this kind of GPU also, where the power is higher than this various kind of processing speed. So that is the reason this is also one of the main thing why we are going to this deep learning. Next is where we spend our time is about training. How much time it is going to take for us to train that particular data. Okay, so the time also matters. Now once you have collected all the data and you have just put it in the form of these three layers, then training, the time taken to train that entire data and get an outcome by passing through all this three layers, that is input layer, hidden layer and output layer, is takes very less amount of time. Once you have fixed and trained that particular data, the next time when you come, you take it, it automatically it generates the kind of data. So it compared to your previous kind of applications, this would get faster. So overall on this, I would like to describe about these three things once again over here. Since we have just discussed about all these things in a definition wise, we will just discuss them as together. Already we have discussed that here deep learning is a subset of machine learning, or machine learning is a subset of artificial intelligence over here. So what is actually artificial intelligence over here? What do we do in that particular field? It is nothing but development of smart systems and machines that can carry out tasks that typically require human intelligence. So what are we doing over here? We are developing some kind of systems over here, smart systems and machines we are developing over here. On top of it, we are using this kind of machine learning. So in machine learning, what we are going to do, we are going to select some kind of algorithms, or we can create a kind of algorithms using the data available and what decisions we have to make. Depending on that, we can create our respective patterns. Okay, depending on the kind of decisions or methods whatever we are taking, the patterns also can be changed. When the patterns can be changed, we can observe the suitable patterns, and as per that we can make kind of selection. So we require human intervention when decision is incorrect. Okay, so whatever patterns are there, and if it is suitable for you, it is fine. But you are going, it is the human who is going to say yes, it is going to be suitable to you, yes, it is not going to be suitable to you. So it is up to you that you are going to select it as it is right or it is wrong. Then coming to this deep learning over here, it is nothing but uses artificial neural networks. And in that artificial neural networks, you must have come across various kind of like algorithms also in that, I suppose. So like convolutional neural networks, recurrent neural networks, otherwise deep learning neural networks, all such kind of algorithms you must have come across. So it is nothing but why actually we are using all these kind of algorithms is to reach out to that particular solutions. Okay, when we reach out to that solutions, and finally that solutions are nothing but conclusions, and there, that is the point where we have to get accurate kind of conclusions without human intervention, isn't it? So it is up to that we need this particular age is like we are defining the kind of system in such a way that it doesn't need the help of a human intervention over here. It has to decide an accurate outcome over here, accurate result, okay, which is going to be suitable to at least a few members, and then the other outcome will be suitable for at least few members, so like that. So this is about introduction to your deep learning over here, and we'll get into some of the concepts of deep learning also over here. Okay, so deep learning is a subfield of artificial intelligence. That's what we have seen over here. And machine learning that focuses on training artificial neural networks to perform tasks without explicit programming. Okay, so we are in combination over here, AI, machine ML, machine learning, and neural networks. That's what is a deep learning over here. The term deep in deep learning refers to the use of deep neural networks. So what is happening over here? This adjective deep, it refers to the use of multiple layers in the network. Whatever kind of deep learning we are trying to perform, it is actually trying, it is representing as neurons over here. So we get to each and every sub level point and train that kind of data and identify that kind of outcome what it is going to be. Okay, so that is the reason we also say that deep refers to the use of multiple layer in the network. As you have seen in the previous example, how the multiple layers from the hidden layer is going to the output layer, and from input layer, how it is coming to the hidden layer. These networks are inspired by the structure and functioning of the human brain. In traditional machine learning, features are manually extracted from data to train models. In contrast, deep learning algorithms automatically learn hierarchical representations of data through successive layers of neural networks. Next, we will just come across the various kind of domains in deep learning, which are which have regained remarkable success in present day scenario. So it is like deep learning has shown remarkable success in various domains, including image recognition, speech recognition, natural language processing, medical diagnosis, autonomous vehicles, and many more. The ability of deep learning models to learn from vast amounts of data and automatically adapt to patterns makes them particularly powerful in solving complex problems and driving innovations across the industries. So, with these kind of advent of what revolutionizing to these applications, it is converging the kind of convergence is taking place in various kind of industries in the form of innovations over here. Now you can see almost every kind of stream or field is adapting to the kind of changes what is happening today. Okay, so the significance of deep learning in today's world. The significance of deep learning lies in its transformative impact on various industries and its ability to address complex problems. So, very complex problems or difficult kind of what unsolvable problems also, you can just get a outcome, a solution, or a conclusion by applying this kind of deep learning concept. Complex pattern recognition. Deep learning excels at recognizing intricate patterns and extracting meaningful features from large data sets. This capability is crucial in tasks such as image and speech recognition, where traditional methods may fall short of this. Okay, so we have seen speech recognition. I think almost most of them have been using this image recognition, otherwise speech recognition, such kind of algorithms also, because over here we need to even define, I think there are many kind of changes which has happened in voice recognition and image recognition also with present day today. It was there earlier, but still there were major changes happening with the involvement of deep learning in that particular respective field too. So next we'll come to this automated feature learning over here. Unlike traditional machine learning approaches that require manual feature engineering, deep learning algorithms automatically learn hierarchical representations of data over here. So even in this particular automated, you can say automated world, automated kind of industries, almost most of the industries have got are working in the form of an automated manner by using these kind of deep learning concepts. Handling big data. Deep learning algorithms thrive on large data sets. So the amount of data which it is going to collect, and then get extract the data out of that, and create a particular outcome which is suitable for multiple people over here. So in that way, we say that deep learning algorithms thrive on large data sets. With the increasing availability of big data, deep learning models can leverage vast amounts of information to train more accurate and sophisticated models. And these are the few highlights which we can go through. That is versatility across domains, enhanced performance in cognitive tasks, real-time decision making, innovation in unstructured data analysis, and continuous improvement through iterative learning, revolutionizing research and development, and economic and business impact. So almost every kind of field has got an impact of this kind of revolution of deep learning over here. Almost everyone have got acquainted with these kind of concepts over here today. Next, what is actually, now we have discussed many kind of definitions over here about what is actually deep learning over here, and everything, definitions of deep learning, how it has been emerged from artificial intelligence and machine learning, what part of that particular thing is called deep learning and all. So now we will see about what is actually here deep learning. Deep learning's role in mimicking the human brain structure and functioning is evident in its design, which draws inspiration from the biological neural networks that make up the human brain. So it extracts in such a way that how you find the biological neural networks, in that way it is going to extract the kind of data. While it's important to note that artificial neural networks are a simplified abstraction of their biological counterparts, there are key parallels in their particular structure. Now, coming to this neural network architecture, in deep learning, this artificial neural networks consists of layers of interconnected nodes or artificial neurons. These layers are typically divided into an input layer, one or more hidden layers, and output layer. That's what we have seen in previous slides. So, whatever kind of input, whatever insights we have collected, or the amount of observation data whatever we have got, that is going to be passed through all these three layers, that is input layer, hidden layer, and output layer. This layered structure allows for the hierarchical processing of this information. So here in this hierarchy of representations over here, we can see the various kind of successive layers in this particular neural network. Most of the kind of extracted data or represented data is heading towards the successive kind of layers by using this kind of neural networks. So based on this, we can definitely say that it mirrors the hierarchical processing of the information in the human brain. Next, we have some kind of activation functions which we have been using in this neural networks. Okay, say in the similar way as neurons use it in that biological form, and this activation is simplified representation of the firing of neurons in the human brain. So it's a similar kind of thing, how we use this kind of neurons, or how the neurons are working in a human this particular brain. So in the same way, we are going to give the observational data as an input, and then as per that it is going to search for the kind of pattern whatever are available, and then as per that it is going to give us some selective patterns, out of which we are going to select the suitable kind of patterns which is applicable to us. In that process, what is taking place over here, it is represented using various kind of weights, strength. Otherwise, it is going to train that particular data using weights or performance or anything like this. And most of the thing what actually we do in this deep learning is learning from data. Okay, whatever data we have, we learn what I said as observation over here. We try to learn much of from that particular data. Much like the human brain learns from experience, deep learning models learn from large amounts of data. The process of adjusting weights during training allows the model to adapt. uh, and all this kind of things over here, and neural networks also we have already discussed about this. And here we are actually seeing many kind of changes in this artificial neural networks and convolutional neural networks over here. And most of you must have already worked in this kind of pattern recognition also. Okay, so this particular concept has is that intact, that it is still being used by most of the kind of applications. Now, coming to the key components of deep learning over here, we have discussed this in the diagrammatic form in the earlier slides. We'll just see them over here as in the form of a layers. The same thing: input layer, hidden layer, and output layer. So these are the three layers which are organized in this neural networks. What it does is it specifies the kind of data. Now when we are saying that it is specifying that data, what is our requirement? Based on that specific requirements, we are going to learn in that particular procedure. We are going to follow up in that particular procedure, and that follow up of procedure is nothing but in the form of input layer, hidden layers, and output layer. Now coming to the input layer, the first layer that receives the initial input data, it is the first kind of layer which we actually initialize the kind of input data. So in this particular thing, what we can expect is from this input layer, what is going to happen is whatever initial kind of input data we have given over here, it is going to be sent to this hidden layers. Now what actually is there in this hidden layers over here? Intermediate layers between the input and output layers, where the neural network processes information. So here the actual processing takes place. Deep neural networks have multiple hidden layers, allowing for hierarchical feature extraction. So here you are going to extract the maximum kind of outcomes, whatever are possible from the available kind of methods. And that is sent as an output layer. The final layer that produces the network output, such as a classification or regression result. Now you can see here, here is being displayed one particular example for various kind of functionalities. We have discussed about the input and hidden layer and output. So how is it actually the function being used, and how we are taking the classification of input and output is being represented over here. So now coming to the function called image classification over here, the input which is selected is nothing but an image. Okay, and the outcome is it extracts the data. Automatic text classification, it now here you can select it in any particular form. Automatic text classification, now you're sending some kind of text as input, maybe the speech recognition or something like that. Maybe from one language you're converting to the some other particular language or something of that sort. Okay, otherwise from this particular text being displayed from English being displayed to Hindi, from Hindi displayed to English, like that you can take automatic text classification. Speech recognition here, so you're going to use your particular voice over here, and then that is converted into a text. We must have seen, we all most of them must have seen experienced this kind of applications over here. Because even if it is in the research, or whether it is any kind of article which we are reading, it takes a longer time where we need to write papers and all that. Most of the time we don't find time with all our busy schedules, so sometimes maybe we'll be using this kind of you must have used this kind of speech recognition also. So automatically when you're speaking with your voice, automatically it displays the text what you have spoken. Machine translation, So here it is like converting some particular text to some other particular form. So nowadays you have, earlier it was like converting your voice into some confined particular language using NLP and all this. But nowadays you have various kind of popular kind of applications which are using, where automatically they are converted into that particular form. So even I think with the help of this chat GPT and all these, we have got acquainted to this kind of thing. And nowadays there are many kind of translators which are coming into existence, where without learning the various concepts of programming languages, we just can convert, switch from one particular language to the other particular language very easily by using, by taking the help of this particular translator. We have the chatbot which takes the input as text, and the response and the outcome would be a text. Sensor abnormality detection. So it is a signal over here which is given as input, and abnormality degree would be displayed over here as an outcome. Even if it is a robot control, it is the sensors which actually send the input, and the actuators are actually checked for any kind of problem, or for it is functioning in a proper way, or in a particular pattern it is functioning or not, we can check. So these are your key components in this particular thing. So now coming to this, we have discussed much about, though it is very few, we have discussed about what is deep learning, and in a way how it is related to machine learning, and in a way how it is related to artificial intelligence, and how we are collecting data, how we are going through all these particular system through these three layers, and how the data is collected on all these we have seen. Now we'll just touch about the particular fields or streams which actually are using this kind of applications over here. One such particular stream or field or industry is nothing but called as healthcare. Okay, so we'll just go through this deep learning in healthcare. Now, what do you find in this healthcare kind of thing is like many of the X-rays, or you need data about any, almost any part of a human body, isn't it? Whether it is a brain, whether it is the eyes, okay, eyes for the vision, for the hands, or for the amputated persons. Otherwise, if it is for your kind of bone structure or something like that, we have been using almost many kind of algorithms are implemented nowadays. And um, and one such kind of topic I would like to discuss is, which I'm working on, that is about a particular disease which needs, and we can process the data using images. Otherwise, we can process the data using the performance on it, and like that. So based on this kind of medical condition itself. Now suppose if we are taking us, there are various approaches how you can get it scanned. You can take a CT scan or something, or some other particular X-ray form, and you can just collect the kind of data from there. So your image is acting as that particular data. Now what we are going to do is, we are going to extract the data from that in the input layer, and that particular data, whatever we have observed in that particular image, that is sent as an input over here, and passed to the already structured kind of hidden data. And as per that, it is going to identify whether any kind of suitable things, and then it is going to let out us a particular pattern, which we can identify that yes, whether the person is affected with that kind of condition. Otherwise, he has medium kind of symptoms, or he has very applicable kind of symptoms, like this in this healthcare. The same thing happens to this drug discovery also. So earlier it was like what it was very expensive and all that, and with the involvement of this kind of convergence over here, what is happening is, it is applicable in this drug discovery also. And personalized kind of medicines have been in making, with the help of these kind of algorithms which are available in this kind of deep learning today. Now coming to this deep learning in retail. So what we do in this particular retailers. Now almost most of them visit the retail stream, isn't it? So whether it is any form of digital, otherwise any kind of what using any kind of platform application or online apps, otherwise any kind of enterprise kind of things, whether offline or online, most of them are visiting such kind of things. So in that, organizations can generate the most significant impressions in digital transformation activities, as long as it is concerned with identifying the much needed reasons for driving deep learning into the retail industry. So as such, you have your business intelligence. Nowadays, earlier how business was being practiced, it's not the same which is being practiced. Now they are trying to learn about the kind of preferences the major kind of group is requesting for, or preference, taste and preference, and then as per that he is going to create the base for that particular kind of data, so that it is available in that kind of market, so that his business can shoot up. Okay, whether it is automation or business intelligence, otherwise CRMs, ERP, IoT devices, otherwise anything. So deep learning provides everything needed to attract people to buy. Even the inventory management also. So earlier it was like we had to wait in the market, if any kind of thing was in the was uh, a huge hit in the market, then people used to wait or starve for that kind of product to be manufactured and then bought into the inventory and then sent for the purchasing. But nowadays, with the involvement of deep learning in that, the inventory management is easily managed looking at by collecting the data from various kind of uh, uh, sites, and then getting the data from that, like what are the preferences or most major groups are requesting for, and as per that the inventory is managed on that, depending on the demand and supply. Deep learning in retail allows synchronizing all online retail activities with offline retail operations, whether generating a customer experience or producing insights from all the noise obtained from the different market and user data. So, almost earlier, how we have visited the particular, whether it is shops or whether it is online business or online purchase or anything, I don't think, or I think you must have found some difference at least with the previous and the present day's practice. The present day's practice is by involving all such kind of features is what they have made them in the form, what you can say, it is very active by collecting the information about various kind of nodes, saying that which particular node is in demand, is demanding for which kind of product, which node is demanding for which kind of product, like that you can trace out this kind of data. A well defined approach to deep learning in retail might assist cut all inefficiencies associated with logistics, supply chain and deliveries, to provide consumers with an adaptable shopping environment. So what is all these kind of things is, obviously it is nothing but to improve the productivity, production, decrease the production defects, and get much more capacity utilization, and reduce the maintenance cost. So it is to infer to all these kind of benefits that this by using the predictive analysis of this deep learning, it is being applied in almost every kind of field, and so happens in the manufacturing kind of field also. Now here, according to McKinsey, deep learning models have the potential to create between 1 or 2 trillion annually in supply chain management and manufacturing, as you can see. I'll just display a figure about what he says. So you can just go through this particular insight. So like it is showing that marketing and sales. Okay, so marketing and sales is between 1.4 to 2.6, 1.2 to 2.0, supply chain management, manufacturing, risk factor, and finance and IT, HR. So this shows like the major group is analyzed over here, to that to achieve the maximum kind of outputs, or whatever capabilities we have seen over here, like that, in the manufacturing. Here, I would like to display some kind of manufacturing kind of concept in this. At the end, I'll just display it for you. Next, under manufacturing, we almost use this kind of concept for quality control and defect detection also, because the quality is what though we are using different kind of approach, the quality is what regains the best performance, or the demand also is increased. So reducing production losses errors is vital for manufacturing firms. Deep learning powered computer vision capabilities are used to automatically detect defective products on time. Consultants claim that some solutions quality testing can identify 90% of defects in specific use cases. So I'll refer you one particular example which everyone must have been experiencing, must have experienced already if you have a car. So, for example, fixing a car's wiring is much easier when the wiring is freshly deployed versus after the whole vehicle has been assembled and painted. So, one such example which displays here image recognition system, I'll just refer to you. Generally, it's not mostly in most of the cars for today. Earlier, it was like only one or two kind of cars would have this kind of system. But nowadays, I think almost most of the cars have this kind of image recognition system here, based on deep learning, which was trained using several million test images. Okay, so earlier it was like available in the Audi car. The system uses pressed sheet metal images from cameras and analyzes them. It is claimed to be successful in identifying fine cracks on the metal sheets. And then here for autonomous vehicles. So for this autonomous vehicles, it uses this particular system, that is ADAS, Advanced Driver Assistance System. So this also we must have seen in couple of cars. I'm not sure if it is available in almost present day cars or anything, but I've seen in a couple of what cars, and maybe much before than me, you must have been experienced with this kind of ADS system over here, which has emerged as a prominent application of AI in cars. So that is advanced driver assistance systems. So it assists the driver in figuring out about the roadmap, or the way the path where he's just moving ahead. So this leverages a combination of sensors, cameras, and AI algorithms to enhance safety and assist drivers in critical situations. Features like assist, lane keeping assist, automatic emergency braking, blind spot detection on rely on AI to analyze sensor data and make real-time decisions. So you can see this one such kind of you must have seen like this. Okay, such kind of path being displayed in the car. Okay, you must have seen this kind of what identification in the cars. So I've just watched in a couple of cars this particular thing. I'm not sure about almost all the cars and all that. So here, this is the path which it shows whether it assists the driver in moving ahead. Okay, to keep them knowledgeable about that particular information. Next, there's another kind of app available over here which you can check that online. So which is called as Rox, conducted his first robo taxi ride. Okay, so it was like autonomous vehicle, or an existing kind of vehicle, where in which the self-driving capabilities using this deep learning what is applied on that particular available cars. The cars are being produced to be robotic ride-share vehicles, where you can book them like Uber or such kind of things. So the website over there which is available is like Zoox, which has conducted its first robotic taxi. So the same thing with self-driving cars utilize a complex network of sensors, cameras, and AI algorithms to perceive their surroundings, make decisions, and navigate safely without human intervention. So companies like Tesla have made significant strides in autonomous driving. So you must have seen this particular car. Okay. So in agriculture, almost in this particular stream also we must have seen the kind of management which is taking place in farming, okay, in crop generating, okay, or pesticide, or the insects, otherwise the pests which are destroying the kind of thing and keeping the live stock over there on in this or aquaculture, all these kind of things. Computer vision models can improve a wide range of farming applications from monitoring crops and producing to livestock. Developing such applications, however, means working with unstructured, unpredictable, and highly dynamic environments in which terrain and targeted objects vary and change constantly. So, in this particular field, also, you have this one particular platform where you can just have a look at how the agriculture is actually being, how the crop monitoring is taking place, and how the pest control is being done. And in case of soil kind of uh, recognition and all that is available in this particular platform that is called as data loop. You can find many kind of what descriptions about how actually this agriculture also is left untouched with this deep learning. So I've managed to get you some uh, picture over here which displays the precision of farming crop monitoring. Okay, so here you can see the pest and disease diagnosis on the leaves. Here you can see the crop monitoring. It is monitoring the crop over here, and you can see over here the soil and the pests and the insects, how they are detecting these particular things in this particular view. So you can see a couple of objects being used for making this kind of agriculture, which is using deep learning and trying to achieve many kind of achievements like never before. So I would like to represent this kind of video for you, where you can understand at least a part of it, like how it goes. I hope you are able to see my screen. One second, I think there's a problem with the link. So these are the few highlights over here, like how what all it is using. GPS, it's using GPS. You can use sensors, drones, and data analytics. So I've tried this particular thing with the field which is available using GPS, and I've seen others using this sensors on their particular fields, and how they are taking the help of the drones in order to utilize that particular things. Just have a view of this video.
When they aren't just fields, they're livelihoods. You want to know everything about them so you can make the right decisions for the crops for your growers. Tyrannus is leading the crop intelligence revolution, providing you insights you need when it matters most. Tyrannus acre-forward solutions put the story of your growers' fields at your fingertips. From early season emergence insights to weeds and disease pressures to late season crop threats. We've assembled the world's largest library of leaf-level images and built the best AI engines to deliver precise insights on threats to crop health at scale. It's all backed by local agronomy experts and a team 100% committed to building a sustainable, prosperous future of agriculture, a team you can count on as you grow. Cover more ground, effortlessly scout from anywhere, and prioritize growers' fields that require the most attention. Act with more speed. Use insights to accelerate decision making, validate recommendations, and get ready for harvest and next year's planting. Unlock more opportunities, engage growers with confidence, and build customized data and agronomy backed action plans. That's how we help growers grow. When they aren't just fields, they're livelihoods. You want to know everything about them so you can make the right decisions for the crops for your growers. Tyrannus is leading the crop intelligence revolution, providing you insights you need when it matters most. Tyrannus Acre Forward Solutions put the story of your growers' fields at your fingertips. From early season emergence insights to weeds and disease pressures to late season crop threats. We've assembled the world's largest library of leaf level images and built the best AI engines to deliver precise insights on threats to crop health at scale. It's all backed by local agronomy experts and a team 100% committed to building a sustainable, prosperous future of agriculture, a team you can count on as you grow. Cover more ground, effortlessly scout from anywhere, and prioritize growers' fields that require the most attention. Act with more speed. Use insights to accelerate decision making, validate recommendations, and get ready for harvest and next year's planting. Unlock more opportunities, engage growers with confidence, and build customized data and agronomy backed action plans. That's how we help growers grow. Tyrannus, Acre Forward.
I think you must have got good insights from this particular video about deep learning in agriculture, like how the sensors are being used and all of this. Now, coming to this deep learning in education. So here, talking about the personalized learning and adaptive kind of assessments we use in this particular educational field. So I guess most of them are in their educational field, and we will often use these various kind of things which are displayed over here, whether it is a forms, it is whether it is a Google form, whether it is Google ads, otherwise related to documents, otherwise creating various kind of documents, otherwise sheets, otherwise slides, and classroom, earth, arts and play, like this various kind of things we have been using with these kind of present day education. So apart from that, we also have many kind of applications or apps with the help of which we can improvise a particular educational field also. Most of the kind of educational field is left untouched because it takes a large amount of time and infrastructure to just implement this kind of scenario over here. But there are available various kind of applications with the help of which each one of us can feel an ease when we are going to collect any information, otherwise extract any information, otherwise on a click getting large amount of data about a particular thing. Most of you must have heard about chat gpt and all this. Most of you must have experienced about all this, which I'm talking about, chat gpt also. So if you already have seen about this chat gpt and all that, mostly you must have heard about this copilot also. Okay, so it's like your everyday companion, so which is coupled up or made up with using AI, and in that even we have this deep learning being used in this particular field. So I'll just try to give you this kind of how it looks like, what is actually this particular co-pilot and all that. Now I hope you can see my screen now. This is how this Copilot looks like over here, where various kind of features are available, like messaging, billing, files, e-signatures, forms, help decks. Like how we find them in Google and all this, like that we find them here over here in a personalized way, which supports a particular educational field. We also get to see various kind of apps available over here. So viewing all these apps, you will get into this about the boardrooms. Okay, otherwise in the boardrooms, taking the points, otherwise forms, creating forms over here, jot forms. Okay, where the clients fill it out directly in the form which is created. You can create such kind of your forms for your employees. And scheduling the meetings or scheduling any kind of events or something like that. And here using these boards, we can create various forms, and various views also can be collected by using this particular thing for data visualization. We also have Power BI. Like this we have many kind of things. I'm sure most of you are quite acquainted with Google Sheets and all that. So the same way others also work. Once if you just can go through, it is very easy navigating through all these kind of things over here. Not only for project management or data visualization of forms, or only scheduling meetings or having videos, conferences and all that also, it is quite yeah, easy for us to use. Like past COVID, what happened is we were all left idle as to how all these things can be changed. Like we had a complete lockdown and we had to take the classes, and so a couple of kind of applications came to our help, and so we started using. With the invent of that particular thing, we also have these kind of supportive kind of applications which are available. With the involvement of these, we can take it to a much higher level. So we have various kind of pricing available in this, based upon our requirement, based upon what our problem is and how the solution has to be got. And this is whatever I have explained over here, whatever I have just told you about, you can just find some kind of insights in this. They say, isn't it, rather than speaking, it is better to show a particular video which throws a good impact on in understanding it. It's like that. So this is how your copilot works. If you want to introduce a product and just enter that particular name, it is going to give out large amount of data about it, how you have to present it, how you have to highlight it, and all that. So he's introducing the product, analyzing data. We used to analyze data using forms, Google Forms. So this works better to analyze and yet represent the graphs, pictorial representation. So this is a scanning transcript. You must have got through various kind of features in it, but actually in this particular video you must have easily understood as to how you have to search, how you have to create for a new, how you can analyze the data which has been created, and all these kind of things. So you have a few more kind of things which is working with GitHub, and directly visualizing the kind of client's data, like analyzing and visualizing it in the form of maps or charts or anything like that. Coming to this future trends, to explore these kind of emerging trends which are available here today, with the involvement of this deep learning, of course that is also left untouched. You can just have a look at this particular future products which are going to come.
The year 2023 is poised to be a groundbreaking year for artificial intelligence, with an array of AI trends set to come. As the capabilities of AI continue to expand, from generative AI models automating tasks to creating new artifacts like text and images. Searching ChatGPT. Log in or sign up. Examples, capabilities and limitations. Talking to ChatGPT. ChatGPT, DALL-E and API. All ChatGPT platforms. Artwork created by AI. Generated AI art is becoming increasingly popular, allowing artists to explore new creative areas and steer away from conventional art forms. Natural language processing has come a long way in recent years. NLP is an AI technology that simplifies language-based processes. Apps powered by AI are becoming increasingly popular, offering users a range of innovative and practical functionalities. Leveraging AI in healthcare is revolutionizing patient care, reducing costs, and increasing efficiency. Also playing a significant role in cybersecurity in 2023, automating security systems and monitoring user behavior to protect sensitive data. Harnessing AI for business success. Harnessing AI for business success requires a well-defined strategy that aligns with employee interests and business goals. Investing in data quality. Investing in data quality is essential to the success of AI and ML implementations, as it ensures that the data used to train AI models is accurate and reliable. Collaboration between humans and AI. Collaboration between humans and AI is set to become a norm in 2023. We can combine the strengths of both humans and AI. Teams can achieve better decision-making, increased efficiency, and improved productivity. The year 2023 promises to be a groundbreaking year for AI advancements, with emerging trends and innovations set to reshape industries.
So I hope you got the future kind of applications which we can use, or which are going to regain in the market over here with the help of this deep learning. So almost all these kind of things which are displayed over your virtual assistants, autonomous vehicles, face recognition, chatbots, sound edition to silent films, colorization of black and white images, all these kind of things with the help of this deep learning kind of concept has created an impact on the future, definitely. And for the future more coming days, we can still more find where to a larger extent major kind of changes which are going to come by. So, and to discuss a couple of real world stories and the impact it has been created with the advent of this deep learning, I'm sure you must have heard a few of them. We have like intro, good meetings, stable diffusion API, higher sure, E-text, Vithara AI, 90, So these are all the apps which are available. Like these are all the startup companies which had invested in this kind of deep learning market and are regaining in the market over here. So with the concepts or things which we discussed so far, using all those kind of concepts, you must have heard about this good meetings over here where you can make a note of all the points which you have where you have attended a meeting. Otherwise you can write a summarization about any particular product. So these good meetings give a free service, and as well depending on the kind of data your data usage, the pricing concept also is available. So this also was quite successful. You can just click in the Google good meetings and you'll find a large amount. It's very easy to understand. It is not like you're learning something in books or checking YouTube videos and all that. Easily you can navigate through each and every section with the help of this particular thing. Next, even you have stable diffusion higher sure, which most of the HRs use this particular app. Next, you have this called 90. Next, minus zero, rephrase, machine hack, all these kind of things which are have created a mark presently, and maybe in coming years it can emerge as an excellent kind of thing, because it has found the dirt in various kind of fields. So where it is, whether it is from recycling of the products, otherwise the dumping kind of things, how are they being sorted out, all the respective kind of fields are being left untouched with the this kind of deep learning over here. Because everything humans had to do all these particular things, but with the involvement of this kind of deep learning, like most of them are quite fascinated, and then easily the convergence is taking place in almost all the kind of respective things. And I would like to conclude with all these kind of streams where the industry is definitely revolutionizing over here. I hope you got few of these insights from today's kind of workshop over here. If it was not much possible, it was not much possible to display each and everything over here. Maybe in some other kind of workshop or session, I would try to create any two examples as a live workout for you, so that you can understand it easily. Today I had to just, since we are discussing about application, I had to touch each and every stream about agriculture, healthcare, manufacture, retail, and financial and insurance. So next time what we'll do is we'll select one particular few particular fields, and just we'll just dig deeper into that particular applications and all that. So these are the summarizing points about the industrial kind of revolution which is taking place with the help of this deep learning that we discussed over here. I hope most of the transformative power of deep learning, which has revolutionized the industries, has been felt by you also. I hope I have conveyed what I had to say, and you have felt the convergence or the transformative power. With this kind of thing, I would like to stop here with my session. Any questions you can just ask. Hello.
Oh, ma'am. Hope session is completed, right, ma'am? I'm sorry, I was in another, I was on another call, so was not able to access this. Oh, sure, you can, ma'am. Please, ma'am. And thanks a lot, ma'am. Thank you a lot. And we'll prepare the certificate for you in another 1 or 2 days, and we'll prepare and we'll send it to you on the require. What are the details we require for the preparation? We'll have a check with you and get the details, and we'll prepare and send it to you, ma'am. Yeah, thank you, ma'am. Thanks a lot, ma'am. Thanks for. Thank you. Thank you.
Okay, thank you all. So I'll sign off here. It was good meeting you here for this particular session, having you here for this particular session. Okay.